Okay guys, so we're going to look at some properties of parallelograms today. We talked about what a parallelogram is in class as we looked at the slopes and we looked at the different angle measures and all the different things that we can use to determine if I have sides parallel. And a parallelogram we defined as a quadrilateral with two pairs of parallel sides. Okay, so that's what you're going to fill in this first blank here. And notice I labeled our parallelogram there. We want it to be a parallelogram ABCD. So we label it in clockwise direction, A, B, C, D. So I want you to label yours accordingly. And the first thing we're going to look at, first thing I want you to do is to go ahead and mark it to match the definition. So since our definition says it has two pairs of parallel sides, we're going to start by marking our sides parallel. Okay, so AB is parallel to DC. And we're going to have AD parallel to BC. So let's go ahead and mark those accordingly. Okay. All right. And let's look at some properties here. And the first property that we have of parallelograms is one you probably already know, and that is that my opposite sides are going to be congruent. So if I look in my picture, and that means we're going to have AD is going to be congruent to AB is going to be congruent to DC, and AD is congruent to BC. I'm going to pick a different color here. I'm going to go back and add congruent markings. So those are a little bit different from the parallel because these are just straight lines. These two are congruent, and these two are congruent. And the reason why that is because if those are parallel, they're always going to be the same distance apart. They're not getting closer or getting further away. They're always the same distance apart. So it always works out that way. Okay. All right, the next two properties deal with the angles. And so I want you to think about what we looked at in class and how we have things that happen with the angles. And that all comes from parallel lines and a transversal. So if I look at AB and DC as parallel lines, then BC could be considered a transversal. And when that happens, this angle, which we're going to call it 110 degrees here, then this angle will have to be supplementary to this angle there. Consecutive interior, and so they wind up being supplementary. So this will be 70 degrees. The thing is because it's a parallelogram, it has another pair of parallel lines. So I can look at AD as parallel to BC, and we'll say AB is my transversal now. And this time, it's this angle that's got to be supplementary to angle A. So angle A would have to also be 110 degrees. So the way it works out is that our opposite pairs will always be equal to each other, and any two angles that are next to each other will always be supplementary because they're always consecutive interior. Okay? So opposite angles are congruent, and consecutive angles are supplementary. So if I know just one angle in a parallelogram, then we know all the angles. And I'm just going to abbreviate here. I'm going to put SUPB. Okay. And I do want you to go in the box that says examples, and I want you to write them out. You're probably going to have to pause the video to get them all in there. But we've got angle A congruent to angle C. Those are these two across from each other. B and D are congruent. And then we've got every pair, every consecutive pair that's going to add up to 180. All right. The third and final property that we're going to look at has to do with my diagonals. And so if we're going to talk about them, we need to see them. So I'm going to come in here. I'm going to use my line tool to make it nice and pretty here. And I'm actually going to draw in a diagonal. Okay. And so I want you to see what happens here. Okay, if I draw in those two diagonals, I can clearly see, well, I hope it's clear, you can tell that they're not congruent to each other. Okay, so AC, it's kind of like if this were a rectangle and it got squished, A and C are now closer to each other than D and B. So they're not congruent, but what happens is it forms congruent triangles. Okay, and so because it makes congruent triangles, then that means the pieces are equal. We wind up with this little piece congruent to this piece. Okay, and it works over here too, but 4 marks is a little much. It's okay, we can do it. Whoa. So they cut each other in half. Okay, and of course the word for the geometry term for that is they bisect each other. So the diagonals will bisect each other. gorgeous. So let's give that intersection a name. We'll call it letter E so that we can label it, specify it in our example box here. And we'll say that AE is congruent to CE and DE is congruent to BE. So if you look in your picture, those are the parts of the diagonals. Okay, so we wind up with some congruent triangles here. This top triangle is congruent to the bottom one, and these two on the left and the right are going to be congruent. All right, so let's go ahead and scroll on down, and let's use what we just talked about to work through a proof here. All right. So we want to use, knowing that this is a parallelogram, and I'm going to do a lot of abbreviation here. Knowing that this is a parallelogram, we want to prove that these two triangles are congruent. And the first thing I want you to notice is that in yours there's a typo. It should say triangle DCA right there. So go ahead and change that. We want to be looking at these two triangles. And we're given, our given information is that we have a parallelogram. Okay? So ABCD is a p-gram. I'm going to abbreviate a lot in here. And p-gram is usually what I use for parallelogram. Okay. So ABCD is a parallelogram. So I want you to think about an easy way to get this. One thing we're used to right off the bat without even using parallelograms is that's equal to itself, right? So we're going to say that AD is congruent. And if you look at the way that they're labeled here, notice that they're opposite. AD, DA is congruent to DA. And we know that that is by reflexive property. I hope you're listening because I don't know if you can read it. Oh, Lordy. Reflexive property. Okay. All right. But then there's, using all those properties up above, there's more than one way to do it. But to me, the easiest way is to work with our sides. Okay. We know our very first thing on the list was that opposite sides are congruent, right? That's a property of a parallelogram. Those will be equal, and those will be equal. Okay. So then we're going to say because opposite sides of a parallelogram are congruent, that means we have AC congruent to BD and CD congruent to AB. Okay. And now we have triangles congruent by side, side, side. So that's it. And you're actually going to find that there's lots of congruent triangles within these quadrilaterals that we do. So I know, this wasn't everybody's favorite thing last semester, but it's not going away. So if you didn't get it, we got to get it. So the triangle ABD is congruent to triangle DCA, and that's by side, side, side. All right, so this is going to go in your notebook on page 69. And we will continue and work through some practice with parallelograms, put these properties into practice tomorrow.